So the final thing to check with your base mesh is the maps. Can you get normal maps out of here? Can you get displacement maps out of here? So let's go ahead and take a look at the process of getting both of those out of here and getting them set up in Maya so you can check how these go. You're going to want to make sure that your mesh is your selected mesh, your active mesh. And you can come up here to the Z plugin manager, and there's a really nifty tool here called the multi-map exporter. And we can go ahead and turn this on. Now, the multi-map exporter allows us to export any type of map we want out of here. You'll see I currently have texture from Polypaint turned on. I'm going to switch mine to normal and to displacement. So these are the two types of maps we're going to get out of here. You can also get things like ambient occlusion, cavity, vector displacement, all sorts of good stuff, but these are the two we're going to get. Now, for the sake of previewing, you'll see it's currently set to 2048. That's perfectly fine. We can go ahead and use a 2048 map for this. Then we can click Export Options and come down here. Now, there are some things you want to be aware of. For example, map border is going to refer to the pixel edge border. So you want to have that to 16 for 2048. If you ever wonder, you can look up the edge padding on Polycount. It's a very good website that will let you see this. So if I come into Google here and just type in Polycount edge padding and pull up this website, you'll see that they have all sorts of good information here on what values to use for what map size. They have a nice little list down here, and basically it just doubles. So if you wanted to go to a 4K map, you'd be using 32 pixels. You want to have flip V turned on, so that way it flips it. ZBrush is inverted. If you remember, we checked the UVs in the last section when we set this up inside of ZBrush, and I mentioned they were flipped, so you do want to make sure those are flipped there. Then the individual categories are down here for the categories we need to do. So let's go ahead and check out normal map. And I'm not going to touch anything because mine are set up correctly, but if this is your first time exporting out of ZBrush, you may have to tweak these. The first thing we want to do is make sure our subdivision level is whatever subdivision level we're going to have in Maya. So in this case, subdivision level 1 is the one I want to use. We want to get tangent normals out of here. If you wanted to get object normals, you could turn this off. Object normals can be good for the texturing process, sometimes for stylized game assets or even stylized film assets. But we want to use tangent for the purpose of tangent space normals. And then S normals here is important to have turned on. This is going to smooth the normal map, and it's going to make it so that the normals look correct. Smooth UV will apply smoothing to the UV. I tend not to use this because it doesn't always correlate one-to-one with the software we're going into. Adaptive supposedly makes it more accurate, but takes longer. This has yet to be seen on my part. Usually, adaptive actually makes things worse. Down here, you have the swizzle space for red, green, blue. You can flip red, green, blue. This is for different channel spaces. For different softwares, you may have to flip these. So it's good to know the swizzle space of whatever software you're going in. And that's basically the X, Y, Z direction of normal maps. The default setup here will work fine for Maya. So that's going to be what you want to have for the normal map settings. Feel free to grab a screenshot of that so you can get it set up. It's pretty straightforward, but any changes can make a big difference. Now, under displacement map, we also want to have specific settings here for the displacement. We want to make sure that the subdivision is set to 1, since that's going to be what we are setting. And then a really important thing to change here is the midpoint to 0. You can see for best results, set it to 0 for a 32-bit. After that, you want to make sure you have 32-bit and EXR turned on. So 0, 32-bit, EXR are all going to be important to set, as well as a scale of 1. That's going to get this 1-to-1 scale inside of Maya. If you don't have all those set correctly, your displacement map's not going to look great. So once again, this is one of those things where I suggest just taking a screenshot here. And as you progress in your career, you'll understand what these mean better. But yeah, for now, probably just start with these settings, and then you can go from there. Now, once we're happy with our settings, we can click Create All Maps. We can then locate our folder, put this into Source Images, and I'm just going to create a new folder here called Relief Maps. Surface relief is the term used for normal maps and displacement maps, and I'll just leave the name as is, click Save, and ZBrush will go ahead and start extracting these maps so we can take a look at these and get them set up inside of Maya. This process does take a bit, especially for the creation of displacement maps. 32-bit EXR files are very large, and they're almost exclusively used in film. You can see EXRs used in games, but it's not really advised because they do take up so much space. It just makes for performance issues, larger download sizes on computers, and just isn't a good idea all around. So yeah, 32-bit EXRs are pretty massive. The TIFF file produced for the normal map is not as large. You could always convert that to a Targa or a PNG in Photoshop later. But when it comes to displacement maps, to get a nice one-to-one correlation, we want to make sure those are being set up in the EXR format. So like I mentioned, this will take a bit of time. I'm going to go ahead and speed up the footage here so you don't have to sit through all of it. But just be patient, wait for it to get kicked out. And if you want something to look at, you can open up the file and impatiently wait, staring at the file to be created, which is what I am going to do here. Open up my relief map folder and just wait for these to be populated into here. Be careful though, clicking off of ZBrush. Sometimes it likes to pause if you do. If you do have this happen where it's like, hey, ZBrush is not responding, you can just click wait for the program to respond and it will generally come back, no problem. Generally. But if it does seem like it's taking too long, you can close it out, reopen it, and just relaunch the map export. All right, so our maps have exported here. I can double click this one and open this in Photoshop. All right, so you'll see now that we have the normal map opened here that we see the normal map. If you're not familiar with normal maps, this is what these look like. And they're going to put our detail onto the character. Now we can also open up the displacement map in here. The displacement map is going to look different. When you open it, you can either choose as transparency or as alpha. I'll just do as transparency, and you'll see this is what the displacement map looks like. Now, the displacement is true surface relief and will actually move our geometry, whereas the normal map is artificial surface relief and will not. Now, we can go ahead and rename these. So I'm just going to rename this human base mesh underscore normal. And then I'll go ahead and rename this one human base mesh underscore displacement. We'll go ahead and take a look at how to set those up next, but that's going to be the process of getting them out of ZBrush. And at this point, we're pretty much done in ZBrush. You can close this out if you want and just resume our adventures in Maya next. All right, so let's go ahead and take a look at setting these up in Maya now. And we'll start out with the normal map because it is the most normal of these two and the most basic to set up. I'm going to switch back to a standard workspace here. We'll just go to General here. And we're going to assign this a new material here. We'll just right-click, assign new material, and we're going to give this a standard surface. And the standard surface here, we'll just go ahead and make this our human base mesh underscore material. And we'll change a setting here of the roughness to 0.5. That's usually something I like to do. And in the color, we could leave this be at the 0.8 if we want, or we could lower this to something like 0.5, a nice middle gray. To set up the normal map, what we're going to do is come down here into the attributes for the material. If you're having a hard time finding this material after assigning it, it will be in the attribute editor, which is located here. And you can click through these tabs to get to the human base material. It may have a different name if you did not rename it. If you come down here to geometry, you can expand this, and inside of here, you're going to have access to bump mapping. You'll click the file input, select file, and then switch this from use as bump to tangent space normals. You can then click the over arrow here to move to the folder directory, select the folder here, which will pull up our source images, and we can go to the relief maps and select the human base mesh normals and hit open. You won't see this at first because we don't have textures turned on. This is the icon that indicates textures are turned on, or you can hit the 6 key on your keyboard and that will turn on the textures inside of Maya. So I'll go ahead and hit 6 and we'll see that relief applied to our object. Now, this may not look quite right, and the reason why is we need to set this to be in a raw format. We can select the object and we can use the pathway navigation here by clicking on these over arrows to get into the file for our normal map. So I'm going to click that once. This will bring us to the normal map. And what we need to do is switch the color space here from sRGB to raw. This differs from Maya to Maya. So the way to do it in this version, which is 2023, is to come into sRGB, come into utility, and just select raw. And that will set this up so we can see the normal map as raw. And you can see now we're getting all our lovely sculpt detail into here onto our model. I can go ahead and unisolate this, and we can have the eyes in there as well. They look a little bit weird with that setup, but there you go. Now, if we wanted to render this, we could go to Arnold Light and introduce a sky dome light to give us some nice lighting around the entire area. Or we could do something a little bit simpler by coming to Create Light and just creating a directional light. For this object, I'm probably going to just do a directional light to get something quick. We can then place the directional light coming at a nice angle here, set its intensity to somewhere between 2 to 3. That's usually a good way to go. And then we can create another directional light on the opposite side of the character and set its intensity down to 1 or 2.5, depending on our preferences. In this case, I'll do 0.5. And this will just allow us to quickly come in here and produce an Arnold render. From there, we can go ahead and open up the Arnold render view. This will take a moment to open because it will immediately start rendering. Okay, so once this is open, we can hit play and let this render. It is going to create a TX file for our normal map, but you'll see we can now see this character inside of here with our detail applied. So you can see how we're getting our nice sculptural detail, even things down into the veins there we're getting. Make sure you have 3 press though, so you can smooth that out. We are getting a bit of a UV seam there, which is concerning. This could be due to the smooth UV. So sometimes if you go into Maya's UVs, that could be the cause because we do have a seam right there. And you'll see when I press 1 and 3, it kind of alters the way that looks. One test to do a mesh display soften normals. This is how we do normals in video games. And if you don't see the issue there, it's not an issue, but if you do see the issue, it is an issue. So that's a situation where we might want to change up that UV seams location. And all the UV seams are actually pretty prominent on this guy right now, which is a bit of surprise. Actually, that's not even a UV seam, it's just prominent looking. I guess that's a viewport issue though. Maybe it's a normal issue. That's kind of interesting. The normals are displaying a bit weird. All right, but that's okay. Either way, we can check this. We could go back and we could, solve the issue, whatever is going to kind of solve the issue in our situation. It could be a lighting situation here. So for example, if I go ahead and delete my non-key light here, my fill light, and we use something like a skydome light, we might notice those issues become less apparent. I could also lower this down. And with this sort of lighting setup, it's still present there. We still have a bit of a snag there. So we'd want to figure that out. That could be a situation where we just want to change the UVs up, make sure there's not a UV seam there. But overall, I'd say this is looking all right. I'm also noticing this line in the head looks pretty prominent there. In terms of the modeling, that's an area we might want to soften out a little bit on the detail. And let me go ahead and attach a ramp to this. If you just come into File here and give it a ramp, it's going to look a little bit better with the lighting. That way we get more of a scene lit type setup. Okay, so that's going to be the process of hooking up the normal map, and you'll see it looks pretty nice in there. We're getting all our details, and we're getting our character set up the way we would expect. Okay, so the next thing I want to talk about is displacement maps, but that will be the process of setting up the normal map for the character. So as a challenge, what I want you to do is go ahead and try setting up the normal map for your character to see how that looks. And just to give you a comparison of a with and without, this is how the character currently looks with. If I click this button, it will remove it, and you can see there is a massive difference between our character with the normal and without the normal applied. It makes a world of difference here. I'm also going to save, just do a quick save scene as, create a new directory here, and just name this render file. And inside of here, I'll just go ahead and make this our human retopology render file and save. Okay, so let's go ahead and explore displacement maps next. Now, displacement maps, if you're not familiar with them, are going to physically displace the surface. So let's go ahead and take a look at an example of an area that's probably going to be obvious. What I want to look for is an area where we have definite height changes. So I'm going to look in ZBrush here at maybe the front of the torso. And you can see how we have a clear indentation of the chest, of the rib cage, of the abdominal, and inside of here in Maya, we just don't. If I go ahead and frame up on these, there's not really a whole lot of separation here. So let's go ahead and render this. I'll go ahead and render this in the render view from this angle. To compare, I can go to View and do a quick store snapshot, and that will store this as a snapshot. And we can compare this after we hook up our displacement. Now, the way to hook up the displacement is to actually come in here to Hypershade, navigate to where your material lives, which is going to be here, and select the input-output connections. The displacement map is a special type of shader, and it doesn't actually go onto materials, it goes onto the shape node. You'll see there's a displacement shader input, and that's going to be where we map this to. Select this standard surface node, and in the attributes here, you can click the file that's associated with displacement material. This will open up your file browser. You can click this. And then inside of here, you're going to get a series of directories. For a standard displacement map, everything's hooked up correctly. We just need to come into File here. We need to select the image, go to Relief Map, and we can go ahead and select Displacement and hit Open. Now, you will notice this default set to RAW. That's the only format that this should be set to. So we don't have to correct that, and we're good to go. One thing you will notice, though, is that we're not seeing a change in our viewport. And that's because these are very heavy to render. I'll show you a secret where we can get this to appear in the viewport, but before, let's go ahead and confirm that's appearing in the render. If I go ahead and hit the render button now, we should see this change to have all the indentation and elevation of our sculpture mesh. And you can see massive difference there between having displacement and not having the displacement. So you can see it's pushing and pulling everything out as we would anticipate it to do. So displacement maps are a very powerful tool that leverages the subdivision of an object to push and pull the vertices. To show you what I mean, let me go ahead and store snapshot again here, but this time turn off smooth preview by pressing 1. You'll see when I do that, the displacement is no longer clearly applied. It still is there a bit, but it's not applying it to the extent that it needs to. So displacement is largely correlated to subdivision. So when you press the 3 button there, you trigger subdivision, and all of a sudden you can access displacement. But notice it is currently only inside of the Arnold render view. And if we take a look at this, our character will look a lot buffer. Now, this lighting is making it look disproportionately beefy, and the combination of the normal map. There's a bit of a debate in the industry if you should use normal maps and displacement maps together. Normal maps are usually designed to capture things like the tertiary details of things like the veins, skin pores, and those sorts of details, whereas displacement maps are designed to do this. They're designed to push and pull the large secondary forms out of the primary forms to get in a really nice looking detailed surface. Okay? Now, the other thing to be aware of is with humans, the material is a bit different looking. If we come into the human base mesh material, I don't know if they have a preset for skin. They do. You can click replace on the preset for skin. You'll notice that it looks quite a bit different than our default material. Skin has a property called subsurface scattering, where light travels within the surface, and it results in softer form changes and softer shadows. So you can see that those forms aren't looking so strong now, and they're looking a lot more natural, despite our character being kind of naked and lacking correct anatomical genitalia. It's also very grainy just due to low quality settings inside of Arnold, but just be aware you can switch that over to a skin shader. I'm going to get it back to our base shader just because that looks a little bit nicer for what we're doing currently. Okay, so that's going to be the way to hook up a displacement. Now, a word of caution on what I'm about to show you. You can get this to show in the viewport. It's very hard to turn off once you have turned on, though. So the secret to getting this to show up is to use a special hotkey when you select your object, and that's going to be Alt-3. What this will do is it will enable displacement on the mesh. So if we go ahead and click Alt-3, we'll see this physically deform, and we'll actually see the displacement in real time now. Just like we were seeing in ZBrush, it reacts to light, it has the form changes, but you are going to notice that there is going to be a bit of lag to your Maya now with this applied, especially with lighting. If you don't have lighting, it won't be so bad. I'm also noticing there's an interesting sort of banding happening to it on the anti-aliasing that I've never really noticed before doing this. My computer probably needs a break and to restart. So that's quite interesting. But that's how you can enable it here. If you hit Alt-3 again, it should disable it, but sometimes it doesn't fully. You'll see the wireframe still kind of poking through and not matching to it. So yeah, just a word of caution if you do apply that and hit Alt-3. It does kind of make the wireframe go a little bit screwy, but there you go. We have it here inside of our viewport. We've gotten out of ZBrush and we've gotten back into Maya, and we can see all those forms in action. So from here, it'd be a matter of adjusting these. I kind of feel like my topology needs to be a little bit adjusted in terms of UV seams. I'm not 100% sure why we're seeing those UV seams so prominently here. Normally, that's not something I notice. We might have to smooth UVs inside of ZBrush since we're coming into Maya and using smoothing. That could be a potential fix, and that may be something to try. Outside of that, moving where the UVs are located would be my next guess. So I might try doing a quick export with smoothing turned on, but I think I'll wrap things up here for setting up the character inside of here and taking a look at displacements. Okay, so as a challenge, what I want you to do is go ahead and hook up a displacement map to your character to just kind of finish this out, and that will go ahead and finish our project. So we started from nothing. We started from a polygon cube. We crafted that into a human, took that into ZBrush, did an anatomy study, brought that back out of ZBrush, did a topology study, took that back into ZBrush and detailed projection, and got our textures onto here, and now we have it in result here inside of Maya. That kind of takes us through the full pipeline of developing a character at a base mesh level. All right, so with that, let's wrap things up here and conclude the project.